This is Dr. Holt. I want to go over one-dimensional projectile motion. In this problem, I have an object has an initial velocity in the horizontal direction of 9.8 meters per second. It's going to go off a cliff here, and it's going to go through. It's going to start falling downward, or following a parabola shape as we go down. And I want to go through just kind of a brief synopsis of how to do the velocities. Now the thing to note here is when this object goes off, its initial velocity in the y direction is 0. So at time is equal to 0, vi in the y direction will always equal to 0 because you have no velocity here. Now let's think about what happens at t equals 1 second. As t equals 1 second, now this velocity is not going to change. You have no acceleration. So through the parabola, the horizontal velocity will be the same throughout. So at t equals 1, we'll see what's going to happen. We can use this equation here to find out what our displacement is going to be in the y, because we have no initial velocity in the y. So we got 1/2 times negative 9.8 times t squared. So what will happen is that 1 second we're going to fall 4.9 meters. Again, just 1/2 times negative 9.8 times time squared. What's going to happen is at this position, again, we'll just clone this because this will be constant throughout. This will not change. Our acceleration now has, in 1 second, has caused the vertical velocity to go 9.8. So my vertical velocity going down is negative 9.8. Now if I want to find the actual velocity of the object after 1 second, then could I not just find the hypotenuse here? Do like a rough sketch here. Let me move this back just a little bit, because each one of those squares represents 9.8. So my velocity at that point in time, after 1 second, would be nothing more than 9.8 squared plus 9.8 squared. Take the square root of that. That would be the magnitude of my velocity. Now let's think about what takes place at 2 seconds. At 2 seconds, if I put 2 into here, I have fallen 19.6. So at 2 seconds, now I'm going to be at this position right here, because I have gone in 2 seconds, I've done 9.8 times 2, I've gone 19.6 this way, and at 2 seconds I've gone, at 1 second I was 9.6 in the y coming down, so here I've gone another 9.6, so I'd be at this position. Now again, my horizontal velocity now will not change. Move that into place. Now my vertical velocity has gone to 19.6. So I want to find out what the actual velocity would be. It would be this value right here, which would be 9.8 squared plus 19.6 squared. Take the square root of that. That would give me a velocity. Now again, you can find the direction where the particle would be, what direction it's traveling, by using just the inverse tangent. Alright, so now let's see, we've done t equals 1, and we've done, to get that back in black, we've done t is equal to 2. Let's see what's going to happen when we do t is equal to 3. Okay, at 3 seconds, now I have moved over 3 of these grids, 9.8 times 3, but again, when I put 3 into here, I will fall in 44.1, which is 4.5 times 9.8. So if I go 1, 2, 3, I'll come down 4.5. That's 1, 2, 3, 4, 5. So right in there, I'll put a little red dot here. Change that to red. Now I'm all the way down to here. Now my velocity in the y is going to be 9.8 times 3. So I've created this vector over here to represent the vertical component. It's going to be back over here. back into place. And then we'll clone this. Move that into place. So my actual velocity would be all the way down to this point right here. Approximately that way. And again, you can find the angle and you can find the hypotenuse. And you can find the hypotenuse by just taking the 9.8 times 3, which is this component here, squaring that, add it to the 9.8 squared, take the square root of that. That'll give you the velocity here. Alright, let's see if we can do one more. Alright, now at t is equal to 4. Do that in black. At t equals 4, I've moved over 4 of these grids. So now I'm going to be over on this area here. Now if I put 4 back into here, I find out how far I've fallen. And at 4, I've fallen 78.4 meters. So I've gone down 8 of those. And where I'm 8 grids, because 8 times 9.8 is going to give me the 78.4. So we'll drop down 8. There's 1, I'm going to do this in red. 1, 2, 3, 4, 5, 6, 7, 8. So we're all the way down to here. Now some of this may not quite fit, we'll see. This is going to be my velocity in the y direction here. I guess it is barely going to fit. Okay, now our horizontal would be the same. That. So now my actual velocity again is going to be all the way down to approximately right in here. Alright, so the most important thing I want you to note from this video is notice how the horizontal velocities never change anywhere along here. The only change that is taking place is going to be your vertical velocities. Now here you notice I moved this over here only because I added. The velocity would actually be at this point here. But again, I moved it over just to help you add. I can do the same thing when you add these vectors. Oops, I don't want to move that. Come back. Maybe I could always move these over here when I add the vectors. Same way I want to do this one. I can move it over here when I add the vectors. So again, horizontal will always be the same. The vertical is changing. The position now is changing as a square of time. And you notice another thing, you're getting a parabola. So if we do a curve, let's do this in blue. See if we can do this very well. We're coming down to here. We're coming down to here. We're coming to here. Again, actually I'm going to come back. I'll do that straight line and be more appropriate for you. Now again, it's not going to be a straight line, but it's going to give you an idea of what the parabola would look like. It would come down like something down further because we didn't do that point on down there. So notice this would be a nice, smooth curve through here, and you're following a parabolic shape all the way through that motion. Alright, hope that helps you understand conceptually how the velocity in the x is being, or horizontal is being held constant, while the velocity in the y is changing, which what it does, again, it gives your shape to be a parabolic shape because you're increasing the magnitude of your vertical displacement compared to your horizontal displacement, which will give you a parabolic shape.